Have you ever wondered why objects fall to the ground? We are taught it's because of gravity, a force pulling everything towards the center of the Earth. But what if this traditional view is incomplete? What if instead of being pulled down, we are constantly accelerating upwards? This is the premise of universal acceleration, UA, a fascinating concept that challenges our understanding of gravity. UA is particularly relevant in the context of the flat Earth model, which proposes that the Earth is a flat disk rather than a sphere. In this model, traditional gravity, with its concept of a central pull, becomes problematic. UA offers a compelling alternative, suggesting that the sensation of gravity is due to the Earth's upward acceleration at a constant rate of 9.8 meters per second squared. This upward acceleration, according to UA proponents, affects everything in the universe simultaneously. It's as if the entire universe is on a giant elevator, constantly moving upwards, creating the illusion of a downward force. This concept might seem radical, but it provides an intriguing explanation for the observed phenomena within the flat Earth model. Imagine yourself standing on the surface of the Earth. According to UA, you are not stationary, but rather on an incredible upward journey. The ground beneath your feet is not pulling you down. Instead, it's rushing upwards, constantly accelerating at 9.8 meters per second squared. This constant acceleration is what we perceive as gravity. Think about an experience we've all had, jumping on a trampoline. As the trampoline springs back, propelling you upwards, you feel a sensation of weightlessness for a brief moment. This is similar to what happens in UA, except the trampoline, in this case, is the Earth itself, constantly accelerating upwards and creating the feeling of gravity. But what about the rest of the universe? According to UA, it's not just the Earth that's moving, the entire universe is accelerating upwards with us. This universal acceleration ensures that all celestial bodies maintain their relative positions in the sky, even as we experience the illusion of gravity here on Earth. The universal acceleration theory directly challenges the traditional understanding of gravity, especially as proposed by Isaac Newton. Newton's law of universal gravitation states that every particle in the universe attracts every other particle with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This theory works perfectly within the model of a spherical Earth, providing a neat explanation for why objects fall towards the center of the Earth and planets orbit the Sun. However, when we consider the flat Earth model, Newton's theory encounters some significant problems. For instance, if gravity pulls everything towards the center of the Earth, then objects located at the edge of the flat Earth should fall at an angle, which is not observed in reality. This is where UA offers a more consistent explanation. By proposing a universal upward acceleration, it eliminates the need for a central point of gravity. In this model, all objects, regardless of their location on the flat Earth, experience the same upward acceleration, explaining why objects fall straight down everywhere on Earth. One of the most intriguing aspects of universal acceleration is its connection to the equivalence principle, a fundamental concept in physics. The equivalence principle, as first proposed by Albert Einstein, states that the effects of gravity are indistinguishable from the effects of acceleration. Imagine yourself in a spaceship far away from any gravitational fields. If the spaceship accelerates upwards at a rate of 9.8 meters per second squared, you would feel a force pushing you down onto the floor, just like gravity on Earth. In fact, you wouldn't be able to tell the difference between being in an accelerating spaceship and being stationary on Earth's surface. This principle highlights a profound connection between gravity and acceleration, a connection that lies at the heart of UA. By proposing that the Earth and everything on it are constantly accelerating upwards, UA offers a unique perspective on gravity, aligning with the equivalence principle and providing a compelling explanation for our everyday experience of this fundamental force.